In today's lesson, we're going to learn about three types of statistical studies. The first one is called a survey. And a survey is a collection of data and is sometimes fact or opinion. The census is a type of survey, as you may be aware of. The government wants to keep track of how many people are in the United States. They do this every 10 years, and they break down all the demographics by race, by gender, by age, and number of people living in each household are just some of the different properties of a census. But that's a survey. An experimental study, also called a controlled experiment, measures the effects of a change. Okay, so as you can see here, I highlighted this part. During a controlled experiment, the researcher will separate the sample population into groups, with one group established as the control group, and the other groups, the experimental group, will be manipulated in some manner except for the control group, which will remain the same. The observational study is a measure of a situation as is. There's no change. The sample population is being measured or surveyed and nothing is changed. A doctor wants to test the effectiveness of a new drug on her patients. She separates her sample of patients into two groups and administers the drug to only one of these groups. She then compares the results. Which type of study best describes the situation? And this would be a controlled experiment because it was broken down into two groups, one being the same, the other one getting the drug. The yearbook staff has designed a survey to learn student opinions on how the yearbook could be improved for this year. If they want to distribute this survey to 100 students and obtain the most reliable data, they should survey every third student sent to the office, every third student sent to the library, every third student sent to the gym for the basketball game, every third student arriving at school in the morning. Well, the most general population would be 4. 1, 2, and 3 would give you some sort of bias or some sort of subset of the general population, because you have students getting in trouble go to the office, academic students go to the library, and those interested in sports will go to the basketball game. Howard collected fish eggs from a pond behind his house so that he could determine whether sunlight had an effect on how many of the eggs hatched. After he collected the eggs, he divided them into 2 tanks. He put both tanks outside near the pond, and he covered one of the tanks with a box to block out all sunlight. State whether Howard's investigation was an example of a controlled experiment, an observation, or a survey. Well, this is a controlled experiment because he divided the eggs into 2 groups, and one of them blocked out the sun and the other one stayed the same. A survey completed at a large university asked 2,000 students to estimate the average number of hours they spend studying each week. Every 10th student entering the library was surveyed. The data showed that the mean number of hours that students spend studying was 15.7 per week. Which characteristic of the survey could create a bias in the results? The size of the sample, the size of the population, the method of analyzing the data, the method of choosing the students who were surveyed. And the answer is the method of choosing the students who were surveyed, because you want to get a most general cross-section of students. The table below gives a set of measures and their respective frequencies. Find the mean of these measures. Well, the old-fashioned way to do this, I know you guys can do this on a calculator. I may have showed you how to type these into list 1, list 2, and then use statistics to find out what the mean is, the average. The old-fashioned way to do it would just be to multiply the measure times the frequency, right? Because there are 2 people that answered 2, 3 people answered 5, 4 people answered 7, and 1 person answered 8, and the sum here is 55. The sum of the frequencies is 10, and 55 divided by 10 is 5.5. So this is the mean. Now with that same logic, I want you to answer this question. The number of minutes students took to complete a quiz is summarized in the table below. If the mean number of minutes was 17, which equation could be used to calculate the value of x? So there's a missing data point here, right? We have a table of the number of students and how long it took them to take a quiz. So 1 student was the slowest, they took 20 minutes, and we had 5 students who were the quickest, they took only 14 minutes to finish the quiz. 16 minutes was how long it took. We don't know how many students, so that's why we have x here. So just like we multiplied the measure times the frequency, we're going to do that here as well. 14 times 5 is 70, 15 times 3, 16 times x, we'll have to leave that as an algebraic expression, 16x, and the rest are the products here. Now we're going to add all these up, 446 plus 16x, and we're going to divide that by the total number of students. And the total number of students is 5 plus 3 is 8, plus 5 is 13, 15, 25, 26, plus x. And that's how we're going to divide 26 plus x, and set that equal to 17 because that is the mean that's given to us. Therefore, answer choice 4 is the equation used to answer this question, how many students took 16 minutes. Now, let's take this one step further. Let's actually solve for x. If we cross multiply and build our equation, isolate x, we have 446 plus 16x equal to 17x plus 17 times 26 is 442. We're going to solve this multi-step equation. And x equals 4. And there were 4 students that took 16 minutes to finish the quiz. And that's today's lesson. It's a study of statistical studies and also how to calculate the mean when you're missing a data point. Best of luck to you.